You're welcome to another episode of Data Analytics for Beginners. My name remains Vincent Hope, your instructor. So today we're going to be dealing with data exploration and cleaning. Now let's jump right into it. What is data exploration? Now let me expand this a bit. Now this involves inspecting the data structure. Means the data set you have, what is involved. Now, inspecting data structure simply means checking the classification. That means under what headings are your data being classified? Is it under names, age, subjects, address, and the rest of it? Now, what kind of data types are in the data set? Do we have numeric? Do we have text data, which is object? Do we have dates? And also, what is the usefulness of each column in your data set? That we're going to be treating extensively later on. Now, let's go to data cleaning. Now, what is data cleaning? Data cleaning simply is the process of preparing variables for analysis. You want to prepare your variables for analysis. It also involves transformation into a format you can work with. That means transforming data into a format you can work with. Data cleaning also involves removing incomplete, inaccurate, irrelevant, and corrupt data. That's also what data cleaning involves. Data cleaning also involves fixing and correcting incorrect data. So that is the brief definition of data exploration and data cleaning. So let's make progress and move forward. Okay, now what's the first step in data cleaning? Data exploration, step one. The first thing you need to do, you need to load the library, the necessary libraries for your data analysis. Now the first library we're going to load is the matplot library inline. You see there's an percentage in front of it, matplot library inline. Now what is the function of this? It tells Python to plot a graph directly below the code. We're going to see how we use this later on. Now, the next thing we're going to do, we're going to import NumPy as NP, which we've done in the previous lesson. Import pandas as PD. Then import the operating system. Now, to display what we have, the data we want to work with, we use the os.list directory /kegel/inputs/Titanic. That means we are looking for the files that are in Titanic, which is under the folder of input, which is under the folder of Kegel. Now let's run that. Now you discover that under Titanic you have train CSV, test CSV, and Genta submission CSV. These are all the CSV files that are under Titanic folder, which is under input folder, which is under Kegel. Now, but we're going to be working with the train.csv folder. So let's make progress. So the step 2 of the data exploration is we're going to load this train CSV, which is the file we saw here. Load this train CSV, which is under Titanic, which is under input, which is under Kegel. We're going to load it using this code pd.readcsv. Load it into this file name here, Titanic_train. So this is what we're going to do. So it says load CSV files into pandas. Now by the time we do that, now this code has loaded it into Titanic train. Now we need to see what is the content of Titanic train by putting the .head code. And when we run it now, we discover that these are the data available in your Titanic train file. We have passenger ID, survived, passenger class, the name, sex, age, subscription, patch, ticket number, the fare they paid, the cabin they stayed and embarked. That's whether they came in or not. Now, the step 3 we're going to do is we're going to check the dataset dimension. That means we're going to check the number of rows in this dataset and the number of columns. Now, if we run this, we use the Titanic undertrain.shape. That's the code for checking the dimension. If you run it, it gives us 891 and 12, means it has 891 rows or records and 12 columns. Let's check the columns quickly. You see, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are 12 columns, and it has 891 rows. So let's make progress on that. Now, we will now check the step 4. We will check the information of the data set. What's data set information? We use the titanic.train.info code. Now, the info gives you a rundown of what exactly the data types and the kinds of data you have in your data set. So we have passenger ID that counts, null counts 891 rows, and none is null. That means all the records are complete. And the data type is integer. Survive, the same thing. P class, the same thing. Now, name has 891 data, no missing value, and the data type is object, which is text. The same thing for sex. Now, age is interesting. It has 741. That means some records are missing because it's supposed to be 891. The same thing goes for cabin. We have a lot of data missing there. So that is for you to understand what exactly is happening on your data set. So let's make progress. Now, the step 5 will be check the data description. Now, you use the Titanic train.describe, and describe actually works for numeric columns. That means columns that have numbers, and the ones that have numbers are passenger ID, survived, passenger class, age, subscription, patch, and fare. Now, we discover that the counts for passenger ID is 891, survived the same, patch class the same, age 714, which we saw previously, subscription 891. So only age in the numeric column has deficiencies of data. Now let's make progress. If we make progress now, the step 6, we're going to take the data description for text columns. Here, this code was for numeric columns. Now for text columns, we're going to work out a code. We're going to use the text. This text doesn't have to be text. You can use any name here, but the code here is equal to Titanic train.dtype. The dtype means the kind of data type. Then Titanic train.dtype equal to object. All the files, all the columns or data that are object or text dot index, you pass them on to Titanic train.dtype and pass them on to text. By the time you print the text, which is this what you see here, and you now Titanic.train.describe, you describe it. Let's run it and see. Okay, it's you run the code. Why is it taking time? Okay, Titanic, let me come down a bit. Okay, run the code here. Okay, it's coming out now. It has to do with your internet connection. It's running out the code now. Okay, it's taking a while. So while it is coming out now, let's check. So we look at the code object. This object, we're looking for all the codes that are object passed to text. Now let's see the output, which is what we've seen before. Why is it taking such a long time? Okay, it's taking a while. Okay, fine, it has come out now. So let's check. Now you can see that index, all the data columns name that have object have all been printed, which is this code: name, sex, ticket, cabin, embarked. Now the description for this text data is that name has 891, sex 891, ticket 891, cabin, a lot of missing values, 204, embarked has 889. That means about 2 records here are missing. You have the unique and the rest of it. So now let's make progress. Now let's check what do we have so far. If we run it again, this is what we have so far. We just explored the data. We've not really done much now. So we still have passenger ID. We still have 1, 2, 3, 4, 5, survive 0, 1, the passenger class, name, sex, and the rest of it. Now we're going to start the proper data cleaning. The step 1 is we're going to delete data columns that you don't need. Now, first one, we're going to delete the Titanic train passenger ID. Passenger ID is just to number individual records. It doesn't really have, may not really have any significance in your data analysis, so we're going to delete it. So this is the code for it. Delete Titanic train, put the column you are going to delete, which is the passenger ID. Then when you delete it, then you now display it again, Titanic train.head, which is what we used here. Let's see whether this will be missing now. We run it. We run the code. Let's go down a bit. Okay. Run the code. If we run the code here, okay, it's giving us let's run the code from here again. Run it here. Okay, let's come here, delete, run the code here. Okay, what is going to give you that error? Maybe something has occurred. Let's take text this up here. Let me go back a bit and run some codes. Let me run this. Okay, it has already deleted the passenger ID, so let me run it back to where it will display the passenger ID and go back to that code. Okay, so the passenger ID is displayed here. So let me come down here and run Titanic head, run it. Okay, you still have passenger ID. So if you come down here, now you now say delete it. When you say delete it, fine now, because that's deleted, because it was deleted before. That's why it's complaint of a code. So it has deleted passenger ID. So you only have survive, P class, and the rest of it. Compared to what you had here, you see passenger ID was here, but now it has been deleted here, so it's no longer available. Now the next step is to sort the data columns to see their usefulness. You also have to know whether any column is useful for your data analysis. So we want to start with the name column. We're going to sort the first 15 records. Now when you sort the first 15 records, this is what you have. You have this names here, Abin, Mr. Tony. Now if you look through, you will discover there's some relationships here. Mr. Albertson, Mr. Samuel, and Albertson, Mrs. Samuel, they are both seem to be couples here. Then you also have Mr. Abbott Staton and Mr. Abbott Rosemary also seem to be couples here. So this is just a display of the name columns accordingly sorted out. Now let's make progress and see what we can do with the remaining of them. Now if we describe the name column, now we have the count of 891. The unique values still 8. Each of them have different names. That's what it simply means. Now let's make progress. Let's check the ticket column, which is the ticket column. So we say Titanic head, Titanic.train, then ticket. Show the first 15 records. Display the ticket column. Now let's see. Here you have from the first one, you have A1, this is the ticket. P, this is, you have alphabet before this. There you have numbers, so they are all seem to be unique. You have some of them starting with alphabet. Now, Titanic, the ticket we describe, let's describe it. Show, so the count is 891, unique 86681. So we have an idea of what the ticket value, the ticket data column looks like. Now, we may not need the ticket column. So since it's not going to be useful for our calculations, we'll simply just delete the ticket column, because tickets may not be able to tell you what exactly, whether the passengers on the Titanic ship died or survived. So we're going to delete it. If we run that code, now you discover that we have only survived, P class, name, age. So the ticket column has been deleted because it's not going to be necessary for our analysis. Now let's make progress. Now let's check the cabin column. Let's click the cabin. Now the cabin column, you check the 15 records. Now you discover that some of them were no record for this. We have C85, no record for this, none. C12, no record, and the rest. Now let's describe it and see what it gives us. Now we describe the column data. You have the count is 204, unique 147. Now the column data, the cabin data itself is going to be useful because we would like to know what section of the ship had more deaths or had more survivors. So we're going to be utilizing this for our data analytics. So we're going to be leaving it. Now let's make progress. Now, to make sense of our data, now we're going to transform some of the variables and give them meaning. We're going to give them meaning. For example, the survived column, which we have seen, if we sort it out, the survived, you can see the data for the survived column is simply 0 and 1, 0 and 1. Now, why 0 represents those who died and 1 represents those who survived. Now, we need to be able to convert it to make more sense so that we can interpret the data more. So what do? We do a kind of transformation. That is the data cleaning step 3, transforming variables or giving variables meaning. So what we're going to do, we're going to use a new variable called new survived. And I'm going to say, pass the survived data under the Titanic train and read it using this code PD categorical and pass it to new survived. Then when you do this code, now you say new survived equals to new survived dot rename categories. That is the categories, everything that was passed here was passed 0 and 1 to this place. Now you are now saying rename the categories into died and survived. Died for 0, survived for 1. Then you now, let's display the final output, which is new survived described. Let's see what it tells us now. Now you see that now you have died instead of died, which is instead of 0, the category is died 549, which is 61%. Then survived 342, which is 38%. So now let us see. Let's change that survived column in the Titanic train to new survived, which is this is the code representing it. Then display the Titanic train and see how it makes sense now. Now let's come down here and see this. Fine. Now you see now, instead of under survived before you had 0 and 1, 0 and 1, 0 and 1. Now you have died, survived, died, survived. So we know those who died. We know those who survived. It makes more sense, died and survived. Now let's make progress. We will do the same for the P class too. Here we just had, if you see like the P class, we just have 1, 3, 1, 3. It doesn't really give us good meaning. So let's make it more meaningful. So this is how you do your data cleaning, more meaningful. So we want to change that class. We say new class, this is the new variable. We now say pass the P class, which is passenger class, in the Titanic train into using this code PD categorical into new class, ordered if it is true. Then we now say new P class, which is new P class, rename the categories. Instead of 1, 2, 3, we have class 1, class 2, class 3. Now we will now say describe. If we run this code here, describe it, you have class 1, class 2, class 3. Then class 1 is 216, which is 24%. Class 2, 184, 20%. Class 3, 491, 55%. Now, let us rewrite the code and display. Now, when I say Titanic.P class, now the column is now new class. If we run this code, now you see now survive, which is what we did before. Now the P class has changed. Now instead of 3 plus 1, you have class 3. Now if you just have class 3, look at the fare they paid. This one paid $7.2. Class 1 paid $71. Class 3 paid $7.9. Let's look at class 2. Class 2 paid $30. So you discover class 3 paid the highest fee among the passenger classes. But now it gives this data more sense. So you are now cleaning your data and rearranging it and transforming it. Now, the next thing you do, you display the data clean step 4, display the unique data. We're going to look for very unique data. So let's take the cabin data and look for a unique data, because we're going to trying to find out if the cabin, which areas or section of the ship or cabins had issues for those who survived and for those who died. So we use the train cabin data dot unique, display the unique values. So we run it. Now we have this NaN is not available. We have C85, C31. So you see some of them have C's, you see some of them have E's, some of them have B's, some of them have D's, and the rest of it. Now let's see what we can do with this data here. Now we're going to transform or give this variable a meaning. Now we're going to take this cabin data, which is this one here. Now we're going to change the type to string and pass it to this character, new variable character cabin. Now, from the character cabin, which is here, we're going to take the first variable of each of these data, each of them, the B's, the C's, and the rest. So cabin 0 for cabin in character cabin, putting them in an array, np.array, then pass it to this variable here, which is new cabin. They will now say new cabin equals to PD categorical new cabin. Now we're passing this new cabin, changing this new cabin into a new variable by putting it in an array, new category cabin, then new cabin dot describe. We describe it. When we run it, we now discover what do we have here. All the variables in this, the first variables, each of them, which was this code we did here, 0, cabin 0 for cabin in character cabin, each of them was picked out, and these are the categories we have. We have A, B, C. So A, we had 15 people, which is 0.1%, 0.01. B, we have 47, 0.05%, and the rest of it. Now, so we have picked out the new cabin. Now, if we now rewrite the column variable, say Titanic.train.cabin, instead of cabin, now we use new cabin. And we now describe it. If we describe it now, we discover now we are reshaping our data set. So the survived is clear now. Who survived, which class they are. Now the cabin, are they in C? Are they in G? Are they in, these ones are not available, so you can keep checking. If you check up to 25 records, if you run the data for 25 records, so that we can see more. Okay, so if it's for 25 records, we see those in the D, the A, so we can use this data also for our analysis. Now, let's make progress. Now, how do you check for non-available values, outliers, or strange variables, strange values? Data sets are most times littered with missing data, extreme data points, also called outliers, and other strange values, and they can negatively affect the result of your data analysis. So you need to work on them. So what do you do? The first thing you need to do is to find how do you detect missing values. Now you can create what you call dummy values. Now look at this code here. Dummy values, a new variable, dummy underscore values equals to pd.series. We have 1 here, none, comma 3, none, 7, none, and the rest of it. Now we say dummy values dot is null to detect missing values. Now if we look at it very well, from the output here, you discover the first record, which is this one, we call it that is missing. The second value is available, true. The third value, false, is here, 3, is missing. The fourth value, which is none, is available, 4. So we have created a dummy value. Now we go, let's describe our age column, because that's what we want to work on. This is our age column. So in the age column, we have 714 values that are there. Then we have, that means a lot of them, about 100 and something of them are missing. So what do we do? Now let's go further. Now those missing values, now remember we defined it here, those missing values, okay, let's continue. Missing values equals to mp.where, this is the code for Python code for it, where it's trying to locate where are the missing values, where in Titanic.age is null. That means where do you find the missing values in this column equal to true? Where do you find it? Now you now say missing values. By the time you run the code, it's telling us in record number 5, record number 7, record number 19, record number 26, 28, and the rest of it. All these records have missing values in the age column. So you need to work on it. Now, so how do you deal with missing values? Dealing with missing values, you replace null values with 0. That is one way. Secondly, you replace null values with the mean or the median of the entire data column itself. That's another way. You input some other values. Then fourth way, you can split the data set into 2 parts, with one where age is not missing and where age is null. Now we will choose to use this one, replace null values with mean or median. just to fill up all these data that are 0, 0, so that you can have a better, it will not affect your data analysis negatively. So to view the distribution of your age plots, of your age, plot a histogram. Remember, we used the matplotlib we loaded that library at the beginning. Now this is where we're going to use it. So that titanic.histogram column age, figure size 9.6 beans this. You can play around with this. So if you run this code, now you look at it, if you observe, you see that you have the highest output between 20 and 30. That's where you have the highest range of data, between 20 and 30. Now, so what do we do? Now, from the histogram, you have age range between 20 and 30. So using a median value of 28 to fill the missing value is ideal. Between 20 and 30, use 28, which is the middle number for this distribution. So now, how do we do that? We can say a new variable, new ages. Remember, it's age column equals to mp.where.age is null. That means wherever there is a null value in the age column and the Titanic train data set, replace it with 28 and the Titanic.train age. Now, now say Titanic _train age equals to new ages, which is this one you just passed now. Then Titanic.age describe. We want to see what happens eventually. Now it is now 891, the count. Remember, the count before we started here, the count here was 714. Now, by the time we replaced the missing values with 28, we are now having a count of 891. Now, if we now do a histogram plot on the current data set, you can now discover that most of the data now have been fixed in between 20 and 30 as 28. So that's why we're having this shoot up here, and the rest of them are almost the same. Now, let's make progress. So that's how we adjusted. That's how we fill the missing data. Now, finally, we talk about dealing with outliers. Outliers are extreme values that lie far away from the typical values of the distribution. Outliers can have significant negative impact on the data analytics predictions. So, to identify outliers, use the fair variable plot. This is a fair variable plot. So, Titanic.train, we want to talk about the fares people paid. Are there people who really paid very high fares? Plot. Then this is the code for it to draw a box plot. So let's run it. Let's run the code. Now, if we look at fair variable plot, okay. If you look at it, you can see this is the average of where all the normal values are supposed to, this green line here. So every other one here that follows up with all these dots, you can see they are called outliers. So these are the outliers. So we want to see where we can exactly locate them. So what do you need to do? So identify the names of those with extreme values who pay the highest fares. You can keep the outliers, that's one of them. Modify or transform them depending on what you think they should be, so they don't affect your values negatively. Now, to transform them, you can say index MP, where that's where are the outliers that have the maximum value in the fare, the maximum value in this fare. That is where in this fare do you have the maximum values. Pass it to index. Then you now say titanic.train.locate the index. When you run this code, when you run this code, let's run it again. Okay, came up now. Fine. You can see now you have it in 3 spots. 258. We survived. He paid $512 for the fares. 679. That is Mr. Thompson. Drake paid $512. Then 739 survived. Three of them survived. That means they were in the high class area. Mr. Lessurer, Mr. Gustav also paid 512. So these are the outliers. They paid very high ticket fares. So then finally, we can now create a new, we can work on create a new variable called family. And that family, we can use the Titanic train subscription. This has this subscription data because we worked on this survive P class. They left the name the same, leave the sex the same. We left the age, the subscription and patch really don't have any value. So let's work on both of them. So with the to do both of them, we can say subscription plus Titanic train patch. We're adding these two. We run it. When we run it, then we now say most family mp.where in this family, which is this new variable we created, has the maximum Titanic train family. Which of them have the maximum? We are trying to work on these two variables now. Which of them? Then load it, find the location and call it into the most family. Use the most family variable, replacing it. So by the time you run that code, you now have this output survived. Then those who survived, the odds ones died. The P class is class 3333. Then the names, the sex, the age not available here. Then subscription, you can see the subscription data here has changed to 8, and the patch here too has also changed to 2, which is the maximum value. Now this is the average fare. Let me run this code. Okay, run this code, which we just saw now. So this is, we run the code, is still loading. Now look at the code now. Okay, so this is it. It came up properly. This is how, okay, it's supposed to come out properly like this. So the subscription is 8 here. The age is displayed here. This is the average age of those who died. The fare, this is the average, the fare itself, 69 class 3. Now, so this is a rundown of how you do data cleaning. You delete the variables that are not required. You transform some of them to give them more meaning so that your data analysis can make more sense. So this is how you do data cleaning, or an example of how you do data cleaning in data analysis.